Hello and welcome to another video. In this video we're going to be working on sort integers by the number of 1 bits. And in this problem you're given an integer array R and you want to sort the integers in an array in the ascending order by the number of ones and their binary representation. In the case of 2 or more integers having the same number of ones, you want to sort them in ascending order. And so pretty much what you need to know for this problem is what a binary representation looks like. So we're going to go over some basic binary representation and then how to actually get the binary representation for a number. So let's just say we have the number like 6. So the way a binary representation works is kind of like decimal. So if you think about it, for decimal, we have 0, 6, right? And the 6, the first number, is the ones place, and then we have like the tens place, and then the hundreds place, and so on. But this can also be represented by something like this, right? This is 10 to the 0, 10 to the 1, and so on. And by what I mean is 10 to the 0, 10 to the 0 is 1. So whatever number it is, it's going to be times this 10 to the 0. Whatever number this is going to be times 10. Whatever number this is going to be times 100, and so on, right? And so for binary, it's very similar. So 6 is actually represented in binary like this. And it's the same way, except instead of 10 to the power, it's 2 to the power. So this is 2 to the 0, this is 2 to the 1, 2 to the 2, 2 to the 3, and so on. And every number in binary is either a 1 or 0 instead of 0 through 9. So 0, 2 to the 0s means it's nothing. So if we add this up, we have 1, 2 to the 1. So 1, 2 to the 1, plus 1, 2 to the 2. And plus 0, and so on. So this is 2 to the 1, which is 2, plus 2 to the 2, which is 4, is 6. So that's kind of like how it works in binary. Pretty much you just figure out like what power of 2 you need. And now that we know like how to get a number, and every number is represented in binary in the actual computer, right? So if you have 6, it's represented in binary. So if we have 6, how do we actually get the number of ones, right? Or whatever number we want. So essentially, it's pretty straightforward. All we're going to do is we're just going to have a loop that counts. So we'll have like this count variable. While the number is non-zero, we need to check the last bit, and we're just going to check, is it a 0 or a 1? And the way to do that, the easiest way to do that is to AND it, to do a bitwise AND with a 1. And the way a bitwise AND works is if you AND a 0 and a 0, you get 0. If you AND a 1 and a 0, you get 0. If you get 0 and a 1, you get 1 or 0, and the only way to get a 1 is a 1 and a 1. So when you do a bitwise AND with a bunch of zeros and a 1, essentially what will happen is this part of the number doesn't matter. But if this part is a 0, then we will get 0 here. And if this part is a 1, then you would get 1 here. And that's all we're concerned for. That's all we're concerned with is that last bit. So what that's going to look like is we will AND it, and we'll get 0, so we're not adding to the count. Then what we want to do is we want to get rid of the number digit by digit until we have, like, we check this digit. So now we want to check this digit and this digit and this digit. And the way we're going to do that, there's a bunch of ways once again, but you can do a bit shift. And what a bit shift does is it takes your number, so let's say you have this, it will shift it to the right. So it will get rid of the rightmost bit, and it will just add a 0 to the left. So when we shift this number, we're going to get 0, 1, 1 now with a 0, and we will AND it with a 1. And now this does give us a 1. So anytime we get a 1, we will just add to the count here. So we'll add 1 to the count. Now we have this number, so we will shift it again, and we'll keep shifting until the number is 0, because that means we have no more 1 bits. So if we shift it, we get 0, 0, 1. Now we AND that with a 1, we get 1. So we add to the count, and we shift it again, and we get 0. And that's pretty much the algorithm, is you just take your number, you AND it with a 1 to get the last bit to see if it's a 0 or 1, or you could mod by 2, right? Because this 1 is just how many 2 to the 0s you have. So if you have an odd number, this 1 will always be a 1. So you could mod it by 2. That's another way to do it, but ANDing it with a 1 also works, just if you're like learning bit manipulation and bit operations. So that's pretty much the algorithm. Is we can even write it down. So take a number, AND it with 1. If that's 1, add 1 to count, and shift number to the right. Do this over and over until number equals 0. And that's pretty much all you need to do. So now that we know how to like get the number of bits, so now let's take our numbers and let's do that. So let's say we have like some numbers. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8. And so what we are asked to do is we are asked to sort these by the number of 1 bits increasing. And if two numbers have the same number of 1 bits, we want to sort them in terms of like the smaller number should come first. So there's a few ways to do this, but the easiest way to do it is go through, make another array, go through each of these numbers, and let's say we have this function called like count 1 bits, right, that we made that uses this logic that I just talked about. So essentially what we can do is we can go through every single number and we can store the count of ones and the number itself. So let's see what that's going to look like. So 0 is going to have 0 ones and 0. Then 1 will have 1 1 and 1. 2 will have 1 1 and 2. 3 will have 2 ones and 3. So remember the count of ones and the number itself. Yeah, and then 4 will have 1 1 and 4. 5 will have 2 ones and 5. 6 will have 2 ones and 6. I'm going to space a little bit, but that's okay. Move this up. There we go. 7 will have 7, I think. So 4, 2, and 1. I think it'll be 3 ones and 7. And 8 will have 1 1 and 8. And if you're not sure what the binary representation for all these looks like, you can try to make these yourself, but these are going to be the correct numbers. Okay, so now what we can do is we can sort this array. And if we sort the array, what's going to happen is it will be sorted automatically by the first thing in here. Like when you do a comparison, they will be sorted by the first number. So let's actually write out the sorting. So essentially, the 3 will go first, right? Because it's or actually, no, it's going to be sorted increasing, right? So the 0 will be first. So if you have an array of 2 items, the way it works is you compare the first 2 items. And if they are equal, then you compare the next 2 items. And what we want is increasing, right? So what's going to happen is the 0, 0 will be first. And now everything with 1, 1, with one of these. So there's 1, 1, 1, and 1. These are all equal in the first digit. So the way the sort is going to work is it's going to compare the second item in all of these arrays. And it will sort it increasingly. So it will automatically sort it like 1, 1, 1, 2, 1, 4. 1, 8. Because since all of these ones are equal, it will compare the second number in the array. That's how like the Python just has like default sorting in there. And if you're using another language, you can just make like a custom sorting function to do that as well. Okay. So and then it will check everything with a 2. So 2, 2, 2. And once again, it will compare the second number because these 2's are all equal. So it needs some way to differentiate them. So the way the numbers are going to get sorted is like this: 2, 3, 2, 5, 2, 6. And finally, the last thing is a 3, so it'll have 3, 7. So now that you have these, you can just make another array, or you can even do like a list comprehension, and you can just say like, walk through this array and just write down the second element from all of these. Because remember, the second element was the original number itself, right? So then we would have 0, 1, 2, 4, 8, 3, 5, 6, 7, right? So just walk through this array in order. Give me the second element. So we are sorting by the number of ones, but if there's a tie, then the smaller number will come first. And that's pretty much what we did. So that's all we have to do is we have to, for every single number, call this like custom get number of ones, store either a tuple or an array of 2 integers, just run sort on it, and then it will handle the work for you. And then finally get all the second digits. So we have 0, 1, 2, 4, 8, 3, 5, 6, 7. And let's take a look at here. 0, 1, 2, 4, 8, 3, 5, 6, 7. Exactly the same way. And this would work exactly the same way pretty much, but that's kind of the idea. So we can write down all our steps again. So make a function to calculate number of ones, like I talked about earlier. That's going to be step 1. Step 2, make new array of each number and make an array of like this. So count of ones and the number for each number. Sort array, return array of all of the second elements in that array. Right? So because it's going to be count of ones and number, we just want the numbers. So just return an array. And actually in Python, we're going to be able to do this with making a custom comparator function. So I'll kind of show you how that works and the logic with that. I haven't really done it before in a LeetCode video, I think. So it's going to be kind of useful. Just in case you do want to make a custom sorting function, you can see how it works. So we can code it up now. Okay. So first things first, we're going to just make that function that's going to calculate the number of ones. So it's a pretty easy one. So we'll just say get 1 bits. It's going to take a number. And all we have to do is have a count. And remember, we're going to say while the number is non-zero, we're going to add to the count if num and 1 is 1. So essentially what this means is if the number and 1 is 0, then we don't have a 1 bit, so you will just add 0. This will value to 0. And then if the number and 1 is 1, then you do have a 1 bit, so this will value it to 1. So then you'll do count plus 1 if there is a 1 bit, and count plus 0 if there's not. Now we want to shift our number to the right 1 time, and this is you could do things like this. It literally means the same thing as this. So this is just like a shorthand version of that. And finally, we want to return the count. So now what we want to do, remember I said like make this new array and get the second element and all these things. So we can actually, instead of doing that in Python, we can actually make a custom sorting function that's going to take an element and sort it by the number of 1 bits. And then it will actually sort this array by the number of 1 bits for us. And the way this works is like so. So we can actually return this array. We don't even need to like store it. So first we're going to call sorted. And what sorted does is it will sort an array, right? So if you do array.sort, this will insort in place. And if you do sorted and you pass in something, it will return a new array, and that's what we want, right? You don't want to manipulate the input. So we will take this, array, we will sort it, but we will return a new array, right? So we're not going to sort this one, we're going to return a new array. That's the sorted version of this one. Okay, and now what this sorted function can take is it can take 3 things. It can take an iterator, which is the array. It can also take a custom key for sort, and it can take, if you want to have it in reverse, you can say reverse equals true, and then it will give you the reverse. So essentially, we don't need the reverse, we just need a key, and the key is going to be a lambda function that's going to take x, and we can return get 1 bits of x and x. So what this means is we will take an x, right? So let's say we take like the number 7, and then we will return get 1 bits of 7, which is 3, and we will return 7, which is kind of what we had, right? And the idea, this is kind of what we had in the picture, right? Where we have the number or the count and then the number. Doing the same thing here, and the reason why you want to have both is because if get 1 bits is equal, then you want to compare by the number. So if you just return get 1 bits and then there's a tie, you didn't really specify how you want the sorting behavior to go. So you can just return get 1 bits and then the number, and then that way if get 1 bits is equal, it will compare by the actual value itself, increasingly in like a normal sorting way. And then we can just run that. And there we go. And efficiency, kind of all over the place. Most of these functions are going to be similar, but let's talk about it. Yeah, so let's click until we get a bigger number. There we go. Okay. So the way this works is basically get 1 bits for a number is a logarithmic function, because essentially what you're doing is you have some number with some bits. It's called 12 bits. And you are going bit by bit. So basically what you're doing is shift is you're dividing by 2. So every time you're dividing by 2, that means for a number, whatever number that is, to get all the bits would be log of that number. So if you call get 1 bits on every single number, the time complexity here would be O of n log n, because each one is log n, and we have n log n. Then we also sort, which is also n log n, obviously, right? So getting all the bits for every number is n log n, sorting is n log n. And the space is, we are just making a return array. Now you might be able to argue like maybe you do have to like make an array to sort it or something. So you might argue like it's actually oven or something because you did like create this thing to sort. Like I think it will create like a temporary array in memory to do all this stuff. So you could argue it's like oven as well if you want to, but I'll just say it's open. And yeah, so that is actually pretty much it for this one. Not too bad. So hopefully you learned how to get the number of bits from number. It's got some sorting thing, kind of cool, kind of useful if you do have like multi-dimensional inputs, you know, not just like a number or a string or something. If you have like a tuple or an array of arrays or something, this is how you could do stuff. And yeah, that's going to be all for this one. So hopefully you liked it. And if you did, please like the video and subscribe to the channel. And I will see you in the next one. So thanks for watching.